what we're going to look at today is why some salts aren't neutral. We might remember that in a neutralization reaction, so an acid plus a base, salt plus water is made. But sometimes that salt doesn't have a pH of 7. And I've got 3 salts here which are going to show this. The first one I've got is sodium chloride, which is made when you put hydrochloric acid with sodium hydroxide. Or it could be sodium carbonate or something like that, but if you do it with the carbonate, it tends to give bubbles, and that messes with things a bit as well, because those bubbles then dissolve in the water and can change the pH. So let's say, for argument's sake, this is made from a strong acid and a strong base. So because both of them are strong, the sodium hydroxide and the hydrochloric acid, we would expect them to cancel each other out perfectly and end up back at 7. So I've got universal indicator in there. I've also got some floaties, so I hope they are not going to affect anything. And I'm going to put some sodium chloride in there, and notice that the colour stays green. So there's been no change. So it is indeed neutral. So it's got a pH of 7. Now, I'm not going to even try and get the pH of these other two, but I'm going to say 7 in that one, and I want to do it the right way up so I don't stuff it up. Okay. In one of your questions, in the piece of work that I've given you to do for homework and over holidays probably, you've got a question about some other salts and justifying their pH, whether it's above or below 7. And here I've got ammonium chloride. Now, ammonium chloride is probably made from hydrochloric acid and ammonia, or ammonium hydroxide. Okay, so we would have a weak base, ammonia, and a strong acid. So what would you predict pH would be, above or below 7?
Below.
Below, because it was a strong acid and a weak base that made this. So we'd expect that. Well, we're going to have a look at that and see if that's right. We're going to then explain it in the next video. This is just the observations one. And sure enough, it's gone a little bit lighter, which on our scale is heading towards the blue. So it's going to be, heading towards the red, so it's actually lower, it's below. All right, the yellow is heading towards orange, which is then heading towards the red. So it's only a little bit below 7, but it is a pH below 7. And the reason mustn't be to do with the chlorides, because this one had chlorides, but had a pH of 7. So clearly chlorides don't affect pH at all, nor does sodium. So this must be due to the ammonium ion. And the simple way to think of it is, ammonium is the conjugate acid of ammonia. So therefore you would expect this to have a pH less than 7. But we need to prove it using chemical equations, because we're doing chemistry, we have to do equations. All right, sodium ethanoate. Now sometimes the sodium is chucked on the other side, so it's CH3COONA. Sometimes it's drawn the way I've got it there. This is made from ethanoic acid, or acetic acid, or vinegar, basically, which is a weak acid, reacted with sodium hydroxide, which is a strong base. So what would we predict would be the pH? 7, below 7, or above 7? Above 7, because it had a strong base. Good. Strong things overpower weak things. And let's have a look. See if it goes a little bit bluer. And it does. It goes a little bit bluer. It's probably easier if I put it next to the sodium chloride or the salt solution. You can see that it's a bit different. You can see it's very different to the ammonium chloride. Those colours are showing up all right in the video, but if they don't show up well, just believe me, this is sort of just gone a little bit bluer than the green it was. This one's gone a little bit yellower, and this one was still the sort of mid-green that it started off at. Right, so sure enough, that wasn't bad, was it? pH is greater than 7. Sorry, you didn't see that in the video. I just fumbled the pen a few times and managed to somehow catch it. So the reason is because of these conjugates. The conjugate base of ethanoic acid is having an effect. It's making more hydroxide ions. The conjugate acid of ammonia, so ammonium, is reacting with water, making more hydronium ions, so therefore bringing the pH down. This one here, though, sodium chloride. Sodium and chloride, once they're ions, that's it. They don't react with water. They just dissolve in water. So the next video is going to talk about the process of dissolving and then the process of a further reaction occurring. So I'll get that one set up and we'll look at that in just a second.